All right, so if we wanted to actually evaluate functions, again, review. All right, so we know what this function is. Every value of x represents some value in the domain. That's my input, right? So this function says, hey, if you give me some value of x, what do you want me to do with it? Well, I want you to square it, then multiply it by 2. Then I want you to add that value to the result of that number times 5, and then take 7 away just for fun. That's what this function, this rule tells me. All right, so if I say f of 4, well, my x value is 4, right? Here's my x. So what do you want me to do? Well, I want you to take your 4, and I want you to first square it, then multiply it by 2, right? So 4 squared is 16 times 2, right? That's going to give us a 32. Then I want you to multiply that value that you gave me by 5. That's going to be 20. And then I want you to take 7 away from that value, right? So this is going to be 52 minus 7, so 45. So this tells us that the point 45 is a point that's on our function. All right, so I'll go a little bit quicker for this one. All right, so if I want to know f of 3, so I can just plug in a -3 everywhere. Really easy mistake to make. I always plug values in parentheses. It kind of helps the mistake of -3 squared is -9, where we know -3 squared is actually like +9 when it's in parentheses. So always a good plan just to plug things in with parentheses. All right, so let's see, that's going to be 9, 18. 18 minus 15 is 3. 3 minus 7 is -4. So this would let us know that the point -3, -4 is a point that's on our graph. All right, so f of t, well, f of t simply means that my input value, my value in the domain is t, whatever constant t represents. So nothing crazy. I still just plug in a t every place that I had in x, right? My value of t is the domain. So this tells us that the point t, 2t squared plus 5t minus 7 is a point that's on our graph. You give me a value of t, this is the y value that corresponds to it, right? When t is 4, well, 45 is going to be the y value that corresponds to it, right? So we don't necessarily have to think of every point as simply a number. We could think of points as having constants or unknown quantities within them. So f of x plus h, right? So this is going to be an important one when we start talking about the difference quotient. So if I just throw in an x plus h everywhere that I have an x, so I have a little bit of work that I have to do here, right? Because it's x plus h squared. So the first thing I need to do is I need to square x plus h. Really common mistake, especially if you haven't done math in a while, is to just say, well, x squared is x squared, h squared is h squared. You have to expand this thing, sometimes called foiling. Right? So if I do this, I'm going to just do the first one kind of like the old school way. X times x is x squared. X times h is xh. I have an h times x and an h times another h. So I'm going to get an xh and an xh. I'm not going to lose the fact that I had a 2 in front of it. That'd be a rookie mistake. I'm going to distribute this 5. So I'm going to get a 5x plus a 5h. And I still have that 7 that's just hanging out being subtracted at the end. All right, so let's see what things I can combine. All right, I'm going to get a 2xh with those values. So I'm going to get 2x squared plus 2xh plus h squared. None of this stuff changed yet. And then I'm going to distribute my 2 to everything inside, and I'm going to end up with 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 7. All right, so looks hideous, but what did we just determine? We just determined that the point x plus h, that whole nasty monstrosity, is a point that's on our graph. If we're being really, really technical, what we've done is if we shift our function over h units, right? If I shift my x value over h units, this is going to tell us how that function results and moves. So we'll kind of broach that a little bit, function transformations. And then finally, this last one, I'll just do it down here. Oops, that's not the thing that I wanted. So we would just have 2, 7 over p squared plus 5, 7 over p minus 7. All right, so if I square, I'm going to square both of those terms because I'm dividing, not multiplying. That's going to be a 49 over p squared. I'm going to multiply 7 over p and 5. Remember, I just multiply the numerators. I don't multiply to the denominator. 35 over p minus 7. So I can clean it up a little bit by multiplying 2 in. I'm gonna get 98 over p squared plus 35 over p minus 7. If I really wanted to, I can combine this. We're gonna find that in my classes, I don't really care a ton about just simplifying things that are just busy work simplification. But what we've just shown is that this is a point that exists on our graph.